Greetings everyone and welcome to today's technical session on assessment of PSC bridges as per CS454. So the focus of this webinar is not only to know the codal provisions, which I believe we already saw for a chunk of part in the earlier presentation, but now we'll try to know how to apply this practically in our project. So how to approach a real bridge assessment project. So in this session, we'll look at the overall assessment workflow, what are the different checks, and how to apply it in your workflow using MIDAS CIVIL NX. So the aim is by the end of the session, you would be able to know how to approach a PSC bridge assessment project using CS454 with the help of MIDAS CIVIL NX workflow. So a brief introduction about myself. I am Bharatiya. I am a technical support engineer here at MIDAS IT. I hold a master's degree in structural engineering from SVNIT Surat. And over my time at MIDAS, I have had the opportunity to work with clients and engineers globally, and which has given me valuable exposure to different practices and different project requirements pertaining to various regions. So at MIDAS, I have worked with engineers from US, UK, and the overall Europe regions, as well as Southeast Asia markets. So currently, I am looking into supporting projects for UK and US markets. So let's get started. So this entire session, this today's technical presentation is divided into 4 simple parts. First, we'll look into the brief overview about CS454 codes. Then we'll look about the different live load models which are to be used for assessment. And then we'll see what is the assessment procedure, what is the assessment verification procedure to be done in MIDAS Civil NX. And at the end, we'll go through a short software demonstration to tie everything together that we already saw. So to start with, what exactly is bridge load rating? So in simple terms, bridge load rating would tell us how much traffic an existing bridge could safely carry today. So we'll be taking the actual site conditions for today's as per today. So it is not necessary to do it only for the old bridges, also for the new bridges it could be done. And we compare the current capacity of the bridge with the standard assessment load models and express this as a factor. So that factor is called the rating factor. So this rating factor becomes a basis for a lot of important decisions. So we'll see later in this next slide, what are those important decisions. So I'll just switch on the pointer. So bridge assessment, as we already saw, it provides essentially about checking whether an existing bridge is still adequate for current loading and the operation conditions. So because of environmental conditions and repetitive vehicle loadings, the bridge is going to deteriorate. So naturally, that is going to reduce the lifespan of the bridge. So that is why load rating is a very key tool in assessment. So it is carried out also for both the ULS as well as for the SLS. And as I discussed earlier, that it will be important for some of the major management decisions. So why that is crucial is because load posting could be required for the bridges, or some of the bridge strengthening processes would need to be done, or the decision whether the overweight load allowances, overweight special vehicles have to be permitted or not, or in extreme conditions, the bridge could be need to be closed completely. So these are some of the decisions that the overseeing organization might need to make. Now let's see the overview of codes. So as you know that CS454 is superseding BD21 and CS455 is also superseding BD44. So it was introduced as a design manual for roads and bridges, and its first revision was in 2019 with a revision later. Now, there were several changes from the old code. So there was inclusion of wind load, thermal load, and HB load models, and also for loaded lengths greater than 50. This was not there earlier, so which has now been introduced. And CS55, which we already saw as the assessment of concrete highway bridges and structures. So these are some of the codes, the snapshots of which you can see on the screen. So in today's webinar, our main focus would be on how these provisions could be applied specifically for PSC bridge assessment. So on the screen, you can see this is like the overall assessment process. This figure shows the entire process. So first, we'll start with the structural review of the drawings, where we'll get the previous assessment. After that, we'll see the previous assessment reports and study them, and then move forward with the assessment. So the highlighted stage over here is the assessment, where the engineering decisions and the engineering calculations come into picture, where we calculate the assessment resistance and assessment action effects in accordance with CS454 and CS455, and check whether it is okay or not, or it is safe to carry the current traffic capacity or not. And then we go with the reporting and then subsequent decisions like whether it needs to be strengthened or not, whether it needs to be completely replaced or not. And then the periodic inspection goes over on. Now we shall see some of the assessment live loads and what are the different levels of assessment. So under CS454, the live loads used for the load rating of PSC bridges are categorized into these traffics. So it could be normal, it could be restricted or abnormal. So under the normal traffic, we'll see the all model 1 and 2, assessment live load model 1 and 2. Then for the restricted traffic, we have the 26, 18, 7.5 and 3 tons. So there are some other vehicle loads as well, but those would be used for masonry arch bridges. So we are skipping that. And the abnormal traffic includes the STGO and SO vehicles and also HB load models. So after that, we can also see the levels of assessment. So there are mainly 3 different levels of assessment. First is the level 1, where the simple structural analysis methods are used and the conservative assumptions are made for materials. Then there is level 2. So this is a more refined structural analysis method where we go for the nonlinear method of analysis. And in level 3, we use the actual site conditions. So the materials derived from the testing samples of the structure and the actual site specific live load model. So this is the more advanced analysis method. So usually we'll start with level 1 and then move forward. It is escalated to further levels only if it is decided by the overseeing organization. Then the assessment verification. So the basic requirement of this entire process is that the resistance of the section is greater than the action effect. So the resistance would depend on FC, condition factor, and also the function of Fk and gamma m, which is the characteristic nominal or worst credible strength of the material, and gamma m is the partial factor for material. Similarly, for the assessment action effects, it would depend on gamma F3, which is the partial factor for load effects, and QA, which itself depend on gamma FL. Again, it is a partial factor for loads and the assessment actions. So now on the screen, you can see this is how a typical assessment report looks like. So on the screen, you can see that we have highlighted what we are going to mainly focus on today. So we'll be focusing mainly on the assessment results. So we'll identify the critical element, then calculate the value or try to derive from the program what is the appropriate assessment load effects, which are SA star, SB star, and S star. And then we see whether it is less than the assessment resistance, which is RA star. And we'll find this out with the help of several factors, which are the adequacy factors, RA star by S star, and there are certain reserve factors, psi star and psi. So we'll see that later how these could be utilized. So to give you a brief idea, adequacy factor is basically the resistance by the total assessment effect, which is denoted by A over here. And there are 2 factors, which are the reserve factors for special vehicles, with standard vehicles and without standard vehicles. So you can see over here, RA star is the assessment resistance and S star is basically the assessment load effect due to the special vehicle. So both these are pertaining to the special vehicles, but one is with standard and one is without standard. So we shall see later what each of them represents. So till now, we have already seen a brief overview about the code. Now towards the later part, we'll see what are the live loads for assessments. So we'll be mainly focusing on all model 1 and 2. So this is the all model 1. This is based on the real vehicle with authorized weights. And it is a single vehicle or a convoy of vehicles, and it is usually suitable for all the kind of structures. So all model 1 is basically the primary live load model used for load rating. From an assessment point of view, this is suitable for all kind of PSC bridges, and it lies upon the engineer to decide which load model to go with. So the next one is the all model 2. So all model 2 is like, you can say, a combination of uniform plus knife edge loading or a single axle one. So we shall see that later. So here, this is like a UDL plus knife edge loads. It is not suitable for certain conditions, which you can see over here, for structures with transversely spanning trough decks or structures with loaded lengths less than 2 meters. So all of these situations won't be handled by all model 2. And as I said, it is on the engineer or the overseeing organization to decide whether which all model 1 or all model 2 to be considered. So you can also go with both. So it depends which one would govern on the structure. So let's go into a little bit depth for all model 1. So the application situation over here is that it is like a single vehicle in each lane or a convoy of vehicles in each lane. The factors to be considered over here are the impact factor, the traffic flow factor, and the lane factor. So this tables would give you an idea of what it would depend on. So whether the road surface is good or poor, and whether we are considering the single vehicle or convoy of vehicles. So it depends on all those different things. So the most critical axle is amplified using the impact factor. So that depends on the road factor over here. So these factors are part of CS454 action model, and it directly affects the action effects. So now you would be able to see that in Civil NX, you can see a snapshot which shows us the different axial vehicles. So here you would be able to see the normal traffic and the restricted traffic. So we can simply choose the appropriate vehicle type, define and whether it is a single vehicle or a convoy vehicle, and select the road surface category. So you'd be able to see the road surface, the traffic flow, as well as you can also consider the contact area. So this contact area could be crucial when you have modeled the deck as plate. So all of this could be done in the program. Now moving ahead with the all model 2. So all model 2 consists of a combined uniform knife edge loads and also a single axle load. So single axle load is not applicable currently not implemented yet in MIDAS Civil NX, but usually it depends on the engineers whether what they want to go with. So combined uniform and knife edge load has been implemented, and that could be utilized. So this is a snapshot from the code. So depending upon the loaded length for the PSC bridge assessment, the governing UDL and knife edge load values can be directly calculated from here. And this also depends on the lane factors, the K factor, and that in turn depends on the traffic flow and the road surfaces, whether it is good, poor, or not. So you can see this is how the UDL plus KEL dialog box look like, the definition of all model 2. Now the application of all model 2 with special vehicles. So partial factors for action, which is gamma FL. So the main advantage over here that it is automatically calculated by the program internally. So depending upon the abnormal traffic actions, whether it is associated and combined with the special vehicles, and whether it lies under ULS or SLS. So there are different combinations, 1, 2, 3, and 4. So the program will pick the appropriate factor. And it is important to note that CS454 governs all these actions and combination rules, and the resulting load effects will be checked against the resistance later. So here you can see the application of all model 2 with a special vehicle, which you can see over here. Now we have seen the live loads for assessments for all model 1 and 2. In the next part, we'll see the assessment verification and the exact workflow which we need to follow in Civil NX. So firstly, we need to define the moving loads. So we need to define the traffic line lanes, vehicles, and moving load cases. So the program, there are 2 points that I wanted to highlight. First is that the program can consider the vehicle contact area. So as I mentioned earlier, if you model the deck as plate, then the vehicle contact area, the tire contact area can also come into effect if you want to consider that as per the requirement of the assessment model. The second is the straddling of lanes. So as you know that EN 1991 suggests the straddling of vehicle code. So whether the SV vehicle lies completely in a notional lane or if it is also overlapping with another lane. So what are the tandem placements for those load models? So that would also be ensured automatically by the program if you straddle the lanes. Now, moving on with the partial safety factors for materials. So here, when you click on this modify design parameters, you would be able to see this dialog where you would be able to define the partial safety factors for materials as per CS455. And by default, these would be the values. And if you want to see, if for the assessment point of view, if you want to see the flexure, shear, torsion, and for the SLS, we have stress checks as well as cracking checks, and for the detailed report, the ULS as well as SLS. So to save time, you can check on the options which you want. So that will save you a little bit of computational time as well. And as you can see, these are the partial factors for material properties as per the ULS and the SLS cases. So you can input them as per your requirement. Then for the definition of reinforcement and the material properties. So firstly, we would need to define the reinforcement and the tendon parameters as well as the profiles and apply the pre-stressing loads as well. So why we are defining this reinforcement and tendon profile or tendon properties is because this would basically be used to calculate the resistance checks, and it will calculate these, it will use this as per CS455 and perform the resistance checks based on the section and material properties that you have provided. So the material property would be provided in this modify material for concrete material dialog, where you would provide the material for the girder as well as for the slab and provide a rebar material for each. Then next step, this I believe is the most important step because this is the assessment load combination where we define the load combination which is required for assessment. So the partial factors for assessments for the actions and for the combination rules would be captured over here. So on the dialog over here, you can see that I have defined 2 for ULS 1 and 2, SLS 1 and 2 for all model 1 and 2 respectively. So you can select the combination type that you need to go with, the limit state and gamma F3. So gamma F3 as per the code, you can select as 1.1 or 1 and choose all the code, all the loads that you want to go with. And the all model 2 vehicle load is captured if you select that from the drop down. And for the partial factors for action, so gamma FL would be automatically captured by the program. So we shall see it later in the demonstration part, depending upon the ULS or SLS or depending upon what are the traffic actions. Now the definition of assessment load combination. So below that, you can see 2 options. If you copy this assessment load combination, then you would be able to get this particular load combinations that you have divided into the usual load combination dialog which you see. So just for the verification purpose, you can use these. And if you click on this copy into general load combinations, then basically it would show you the assessment load combinations itself. So next is the definition of sections for assessment check and report. So here we will define the concrete sections or the elements that we need to use for checking as well as for the reporting. We also specify the relevant SLS classes over here. So that would basically be used for the stress checks as per the tensile limits as well as for the compression limits, depending upon the class that you define. So SLS 1, class 1, 2, or 3. Now we can see the reserve factor. So now we are moving ahead with the results part. So in the flexure reserve tables, you can see that this is the table that would be generated. So a detailed look would be provided when we go for the demonstration part. So this is what the program has taken. The assessed resistance is basically calculated from the CS455 stress range relationships and the material models that we already have defined. And that is compared with the assessment load actions that we have defined as per CS454. So the reserve factors and the adequacy factors clearly indicate how much flexural capacity remains for each of the governing load cases and positions. So this is for element number 3 only. Similarly, we can see for the shear reserve factors. So there is a small flowchart given. So the program internally would check whether the section is cracked or not. So each of them, the shear is different, and then it is checked whether the shear link is effective or not. If it is not effective, it is ignore the shear rebar. If it is effective, it will calculate the VS as well. And VU would be the VC plus VS. So in this case, VS is basically going to be ignored. And at the end, it is going to verify the maximum shear. So that is going to be the workflow for shear checking in MIDAS CIVIL NX. Similarly, for torsion, it will verify if VT is greater than VT mean. And again, it will check whether the torsion rebar is needed or not. If it is, for both the cases, it will check the ultimate torsional strength TU, and then it will check the shear stress due to torsion. And later, it will also calculate the shear stress due to shear, and then it will compare whether VTU is greater than V plus VT. So it should satisfy this check. I have not provided a snapshot because in the demonstration, the section that we are going with is a composite I section, and the torsion verification is skipped for open type of section in MIDAS CIVIL NX, but it will perform these sections for closed sections like PSC box girder sections. For closed or torsion sensitive PSC sections, the program would be able to evaluate the torsional resistance. And this is the serviceability verification table. So SLS checks would be performed over here. You can see this is the stress checks, and here it would show the serviceability like in the form of crack checks and the crack width checks. So this would allow us in conformation with CS455, which we earlier saw as per the classes that we defined earlier. It will calculate the allowable stress limits from there. And at the end, it will also tell us whether it is okay or not. So this would be give you a better idea of whether sections are passing or not. So if it is not good, the line would be highlighted in red, which would tell us that it is not good, and we would need to make certain modifications in the model. Then at the end, we are going to see the report. So this is how the report is going to look like. This is MS Excel based report format. And the report clearly separates the assessment input, the applied combinations and factors, the resistance calculation which are being calculated with respect to CS455, and those are compared. So this is the flexure design check, the shear design check. So we shall see in detail later. And this is the SLS checks. So till now we have seen the reports as well. So we are also done with the assessment verification. Towards the next part, we'll start with the software demonstration. So let's start the demonstration part. So just to give a quick overview of the model that we are going to perform the load rating for. This is a single span composite PSC bridge, and as you can see, we have performed the construction stage analysis over here. And we have also incorporated the time-dependent effects, and we have defined the reinforcement. So just to show the reinforcement, we'll go to the section manager reinforcement, and we have provided the reinforcement for the mid section. And if you want to see the tendons as well, so let's just click on any one of these for now. Let's check the tendons and the reinforcement bars. It is going to show the exact position of the tendons as well as the rebars. So after this, to see the loadings, or rather the boundary conditions first, let's activate all the boundaries. So you would be able to see the boundaries. If we go to CS1, you can see that the only girders are activated with the temporary supports, and we have performed the pre-stressing as well. In stage 2, again, there is no element activation, but there is the partial pre-stressing. So in stage 1, there is certain pre-stressing. In stage 2, there is another set of pre-stressing. In stage 3, we have the wet concrete loads. So if I activate them, you can see that in stage 3, we have wet concrete loads. And in stage 4, we have deactivated the wet concrete loads. And the deck itself is activated as the element itself. And also the diaphragm is casted, which you can see in orange over here. And if you go to last stage, now you can see that the supports have been shifted to the bottom of the girders, and it has been connected through these rigid links. And also at the last stage, the crash barrier loads have been activated as well as the wearing port loads. So if I display, this is the crash barrier loads and this is the wearing course loads. So after this, let's go to the base stage again. And apart from this, we have the temperature loads and wind and earthquake loads, static earthquake loads. So we'll leave that for now. So we'll be mainly focusing on the load rating procedure now. So we already saw that we have defined the reinforcement as well as we have also provided this tendon profiles, and also the pre-stressing has been applied. So that would be helpful when we go for the capacity checks. Basically, the resistance of the section is going to be calculated from the reinforcement that you have defined and the pre-stressing. So we have defined the tendon profiles and the pre-stressing. So the next step would be to start defining the moving load. So for users who are new to Civil or Civil NX, the workflow in the program is divided into 3 steps for the moving loads. Let's select the code first. So I'll select BS. So as you can see over here, it is basically divided into 3 steps. First is we need to define the traffic lanes. Then we need to define the vehicles. And at the end, we need to integrate both of them together in moving load cases. So let's start with the definition of traffic line lanes. I'm going to undisplay the boundary conditions. So let's start with the lane 1, and I'm going to define the name as lane A. Let the wheel spacing be 1, and we are going to give certain eccentricity over here. So that is going to be minus 1.5 meter. So we are going towards the positive y-axis. So that is minus nomenclature wise. Now it is going to be distributed in cross beam, and let me check again with the dummy group. Yeah, it's going to be slab for the cross beam distribution. And since there is no skew, we'll skip that, and we are going to select the first girder location, which is this. Select it again. So once that is done, I click on apply. You can see this is lane A. Now second is lane B. And we'll change this to minus 4.5. And then lane C at the end. So we are only going to define 3 lanes in this case. We've defined all the 3 lanes, which you can see in the tree menu as well. Now the next step would be to define the vehicles. So I'll click on add standard, and I'll first select CS454 assessment as the code, and we'll select A4XL over here for our model 1. And we can also consider contact area if you want, if you have modeled the deck as plate. Here it's not going to matter, so I'll just click on apply. And then we are going to select all model 2. So again, over here for the K factor, you can select the traffic category as well as the road level. So that is going to help in the calculation of K factor. And here you can see this is what the code has prescribed for the values of UDL and knife edge loads as per the loaded lengths. And after this, I'm going to select the special load, mainly because we need to select the special vehicle as well. So you can select any of these from the drop down. I'm going to go with SV80 and I click on OK. So I have defined all model 1 loads, 2 as well as the SV80 special vehicle loads. Now, although I have defined, it has not been integrated into moving load cases. So I'm going to create moving load cases over here. So I'm going to give the name as ULS all model 2. We select CS455 for assessment, all model 2 and special load as the code, as the load model type. And we'll check on auto live load combination. It will help us in the program to automatically pick up the gamma FL factors. So since this is ULS, I'll stick to ultimate limit state and we'll go with combination 1. I'm going to select all model 2, SV80, and all the 3 lanes I'll bring to the right. And as the Eurocode has prescribed to consider the straddle effects as well, I'm going to straddle between lane A and B and lane B to C. So I'm going to apply this over here and I'm going to create one more for SLS. So I'm just going to make one change. I'm going to select SLS from here, apply it, and now I'm going to create for all model 1. So this has all model 1. It has to be ultimate limit state. And everything else again remains the same. SLS. So in this case, we have created all 4 moving load cases. So it lies upon the engineer to whether they want to model only ULS and SLS of all model 2 or only of all model 1, or they want to consider all of them. It lies on them, on their engineering judgment, which they think would be governing. They can incorporate that into the program. So once this is done, we'll go to analysis, moving load, and firstly, I'll be defining the. Here you can input what number you want to enter as the influence line generating points. So usually 3 would work. I click on OK. And once this is done, we can move ahead with the rating part. So let's go to the rating tab. Firstly, we'll be selecting PSC bridge from the drop-down. And as you can see here, this is only for composite bridges. So this is PSC composite bridge tab, and I'm going to select CS45420. From the assessment code option, I am going to select the rating code again in the assessment parameters. If I click on assessment code parameters, here you can define the condition factor. And if you click on this modify design parameters, as we discussed earlier in the presentation as well, here you'll be able to give the characteristic worst credible strength factors and also the partial safety factors for materials. So I'm going to click on OK because I'm going to stick with the default values. And for the ULS, if you want to consider the flexure, shear, torsion for serviceability limit state, for in the form of stress and cracks, and for the detailed report, ULS as well as SLS. So you can check on all the options that you want to check for, and you can check anything off if you don't want to, you are not interested in that particular component. And apart from this, there's also a clause in CS454 about whether if there are inclined tendons and if you want to consider the vertical component of the pre-stressing force to add to the Vmax criteria, you can check on these options. I am currently not checking that on. I click on OK. And you can also define the environment type if required. I am skipping that part for now. In the modify material, you need to assign the material. So here, as you can see, I have already defined that. If not, you can select the girder and the slab's concrete material, as well as the rebar material for girder, as well as the slab. So I have selected C3545 as the grade for slab and C4050 as the grade for girder. And for all of this, I have selected S400 as the grade of main rebar as well as the sub rebar for the slab as well as for the girders. So I'll close that now. Now we'll go to load combinations for assessment. So this is the most important step for defining the cases. So firstly, I'm going to create ULS all model 2. Let the limit state be ULS combination type combination 1 and gamma F3 will input the values as prescribed by the code as 1.1. For SLS, it will be 1. So from here, from this dropdown, we are going to insert all the static load cases that are going to be that we need to consider for the rating part. So I'm going to select crash. I'm going to select the varying code loads, the dead loads, as well as the tendon secondary effects. And I'm going to give the factors. So this is going to be 1.1. 1.75 is what the code has prescribed for the varying surfaces. And again, 1.1 for tendon secondary. Now, in the moving load cases and factors, we'll be going with auto MVL case because if you remember, for the definition of moving load cases, we checked on the auto live load on. So that is why it's coming over here, and we can select ULS all model 2 from the dropdown. So here, as you can see, we don't need to define the gamma FL, mainly because the program will automatically consider the gamma FL factors. We don't need to consider that. Now, similarly for this, I'll just click on copy into assessment load combination, and I'll modify this to make it QLS, SLS, and I'll select SLS from here and give the gamma F3 value as 1. And additionally, I also need to consider tendon primary in this case. So, and apart from this, I also need to select the moving load cases as SLS all model 2. So once this is done, I'll go back outside and I'll just confirm this is ULS2 and SLS. So these are for all model 2. If you want to create for all model 1, you can create them as well. So let's just create another one. So this would be for ULS, but for all model 1. So there's only one change that we need to make over here. Mainly that is for the auto MVL cases, which is ULS all model 1, which is what I need to select. Similarly for the SLS, I copy and rename it as SLS1 and select SLS1 from here. So just to verify, ULS2 contains ULS all model 2 and everything else is correct as per the factors. And ULS1 has ULS all model 1. Similarly, SLS2 has SLS2 as the moving load case. And this is SLS1. So factors, we forgot to modify the factors for SLS cases. So I modified them now. I'm entering 1 for all of these cases. So we'll verify it once again, and that's done now. We'll close this. We have already defined the load combination cases. So after this, what you need to define is the section for assessment. So section for assessment check as well as for the report generation. So ideally, you can get the critical element. If you already have identified the critical element, you can enter those over here. So for this case, I am going to define, I have already defined 3 cases, which is 3, 7, and 51. So if I show it over here, so because we have only defined the reinforcement for the mid section and not for the other section. That is why I'm going to consider only mid section. So if I show you the mid sections, these are all the mid sections, and I'm going to consider, if I show you the element numbers, I am going to consider element number 3 element number 7 and element number 51. So you can enter them. I can delete them and show you again. I'll delete this. And over here, I can check on 3, 7, and 51. I can enter them over there. Then enter only those 3, 7, 51. And you can see these 3 elements are selected. And I'll apply that after selecting the class category. I am only interested in ith position. So I am going to I position and class category as class 1. I'm going to apply that. Similarly, for the check for report, for the assessment report. So what exactly do we want to see in the report? Let's stick with the earlier elements 3, 7, 51, and I'm going to apply it. So the check will be useful when you want to basically see all the results in the tabular format over here. But if you want to see the detailed calculation to be shown in the report, the MS Excel based report which is generated by the program, then you need to enter those elements in the report. So if I show you the report, I have 3, 7, 51 in the report. And for the section check, I have 3, 7, 51, the same elements. And I have only considered the ith end of these elements. So once this is done, we can move ahead with the results. So you can perform analysis. So just to save time, I have already created a model with the same inputs, and we are going to study and analyze the results in this model. So firstly, I'll show the forces. You can see the beam diagrams of the moving load cases. So ULS all model 2, ULS all model 1. So all of that we have already defined. If you want to check on the legends to see where the load values are, where the bending moment values are ranging, you can see them over here. So what we can do now is to study the moving load tracer results. So if I go to results, moving load tracer, and let's see the beam forces. So moving load tracer would be useful when you want to see the critical vehicular position. So let's say for element number 3, which is lying over here, if I want to see what is the critical vehicular position that induces the maximum moment in that element, in the ith end of this element, then I would be able to see that exactly. So let's click on apply. So this is for ULS all model 2. So if I see this, you would be able to see that the program has placed special vehicle on the first lane. On the second lane, it has placed the UDL plus knife edge loads, and again for the third as well. So you can also verify these values. Firstly, you can see that the maximum moment in, let me check off the legends. The maximum moment at the ith end of element number 3 is around 3677 kilonewton meter. And let's start first with where these values have come from. So I have a small Excel sheet just to show load verification kind of thing where we verify the ULS model loads. So firstly, the special vehicles is pretty straightforward. If we see it has applied a factor of 1.1, that is what we had defined for the load effects. For the others, if you want to verify the loads like this 26.39 and where this 8.55 has come from, we can also verify them by checking the Excel, and the code has prescribed the values. So before that, if you want to see what is the lane factor and what is the traffic lane factor, what is the K factor that the program has considered, as well as what is the loaded length that the program has considered, because loaded length is not the bridge length, but the worst effect which is captured from the impulse lines. So if you want to see what that loaded length is, you can click on this detailed result. So that would give you each lane's detail. So rendering this on this screen, you would be able to see that for the first lane, which is lane 1, which is the most critical lane, in this case, the loaded length is 0, so it won't matter over here because that is going to be, as we can see over here, it is loaded with the special vehicle. We'll keep our focus on lane 2 and lane 3. So lane 2 loaded length is 25 meter. So as you can see that this is the lane 2, the middle one, and it is loaded entirely. And you can see the factor as well for the vehicles and everything. So let's check the Excel sheet again. So we are currently interested in lane 2, which is 25 meters. So let me just write it down over here. So lane 2, it is 25 meter loaded length. What we get as UDL and knife edge load is this. So we have directly calculated this from here. So this is the formula that I have used. And K factor is 0.91 for the factors that we have entered, depending upon the traffic category and the surfacing and everything. The lane factor is 1. N is the number of points. So basically that is going to be divided into 4 points. That is why I have considered 4. As you can see, 1, 2, 3, and 4. Gamma FL is taken as 1.3 by the program. So let me again show the model that we were checking. Let's go back to Excel. So as you can see that the UDL and knife edge load comes out to be 8.55 and 26.39. So I've just multiplied this and divided it by the number of points, which is 4. So 28.9 multiplied by 0.91 times 1 times 1.3 divided by 4. So that is what I have got the value of UDL from, and similarly for the knife edge load. So we can confirm this is 8.55 and 26.39. 8.55 and 26.39. Similarly, for the last lane, the loaded length is 8.17. So I'm just going to copy this. And here you would be able to see that the partial factor for abnormal traffic, in case there are special vehicles, the factor would be taken as 1.1. In normal conditions, the gamma FL factor would be 1.3. So that you can also use this for small verifications at your end. So let me substitute this value over here. And here you can see that UDL is 6.65 and knife edge load is 24.25. So that would be confirmed by going over here. This is 24.25 and this is 16.65. So that is confirmed. And this can be used for small verifications and examples like that. Once this is done, let's go to the tabular format of the results. So when I go to the results, result tables, and let's focus on one element. Let's just focus on ith end of element number 3. So I'm going to go with beam forces. I'm interested in element number 3, I end, and I want to see the results of ULS all model 2 for MV max case. So as you can see, this is exactly same, which is displayed over here. 3677.59 kilonewton meter. And now, if you want to see that what is the moment that is generated at the ith end of element number 3 due to special vehicle and due to standard vehicle. So program would also, MIDAS Civil NX also provides that bifurcation. So if I go and right click over here and click on view by load cases, and I'm interested in moment Y, I would be able to see that for the standard vehicle and for the special vehicle, what is the moment that is generated. So the total moment is 3677, but out of that, 831 is due to the standard vehicle and 2846 is due to the special vehicle. So that also makes sense, because if you see the ith end of the third element, you can see that the special vehicle is loaded just on top of that. So that is naturally it would have more effect, and that is captured over here. So this would also be very helpful when you want to calculate the reserve factors in the form of psi and psi star due to the special vehicle with or without the standard loading. Then it is also helpful for that if you want to verify the small stuff manually. So it would come in handy. After this, let's go with the results again, and let's study the results of the rating. So we'll go to initial view again. Let's go to rating. And let's go first with the flexure reserve factors table. So we only have performed for the ith end, so I'm going to check off J. And firstly, you can see the RA star, S star, SD star, SST, SS star. So as we already know that RA star is the assessment resistance. S is going to be due to the standard loads. S is due to the summations of S is due to the special vehicle. SD is due to the loads. SST is going to be the standard vehicles assessment load effect. SA is just the summation of all of these. So A is, as you already know, that A is the resistance factor divided by the SA star. And for the psi and psi star, we already know what this means. One is without the standard loading and one is with the standard loading. So after this, in the rating case, you can see that multiple cases have been created. So here you can see for the ULS1. So let's go with ULS2 in this case. So we'll be focusing on all of these. So over here, let me check off the tree menu 2 and let me zoom in. So here you would be able to see that there are multiple cases. So these are 12 in number. So 6 components, each has its own max and min. That's why it has 12. So these are just the concurrent forces. So these forces also you would be able to see in the software. So RA star is basically the capacity. So that is done as per the CS455 provisions. But if you want to see where exactly these would lie, like the S star, SST. So if you want to see them, let's go back to the model and let's focus on element number 3, ULS2. Now let's try to verify where exactly these values would come from. So firstly, we'll go to rating and load combination for assessment. If you are interested in ULS2, I'm going to copy this into general load combinations. So I've copied this. And now if I see the load combination results, load combinations, basically I will be able to see all of these. So I'm going to delete these load combinations mainly because I'm not interested in the design now. So here you can see the ULS live load case and ULS2 is what we are interested in. Close this. Now we'll firstly go to beam force results, and since we are interested in ULS2, I'm going to activate that combination. So that was ULS2 max mean case. ULS2 max and mean. To activate that, and here you will be able to see the moments. So this moment, we are trying to verify where this value would come from. So I'm going to activate, I'm going to view by max value item because I want to see for all the cases. Zoom in. So these are the different moments that I have captured. So let's go to Excel. We are not interested in all of these, so you can just skip this. Paste it over here. We already have the formulation ready, and also paste this over here. Now we can confirm where those values comes from in the flexural reserve factors, as you can see. So for the FX max case, the moment was around, minimize this. I would be able to show you both at once. All right, so this is where 7781.521 comes from. This is 6102, which is over here because first we are seeing the XGL one, so these two are matching. Similarly, all the others are going to match. So this is the SS star, and that can be confirmed and seen in the results by converting those into the general load combinations and then checking the results of those by max value item, basically the concurrent forces, and applying the factor of 1.1. in this case. So once we have verified this as well, then we can go to the rating results again. And let's check the shear one. So similarly, shear can also be verified. I am skipping that portion for now. You can verify that at your end. And for this case, as you can see, all the sections are currently passing. But if any of the sections is not passing, as you can see, one of the near the support sections that we have taken is showing a lesser value of A, and all the other are having much higher value of A, mainly because there is not much shear near the mid sections. So you can verify these values also at your end. After this, the torsion one. So torsion will be skipped in this case. So you can just leave this. And the SLS reserve factors. So you can see a lot of red, which means that it is failing. And it is marginally failing. It's not like it's failing by a huge amount, but it is failing. So we might need to make some modifications in the model, in the material, or in the reinforcements, and then try to get this under limit. So let's change this units to MPa. And you can see that the limiting value is 16. And what we are getting is around 18, 19 in some of the elements, some of the cases. So we can make those modifications. And as the tension is not allowed in any of the elements as per the code suggests, so you can see some of them have some tension. So that is not allowed. So we might need to modify those. And you can see all the sections, all the elements which are highlighted in red are failing. All the cases are failing. So you can see element number 51 is passing, but element number 3 and 7 are failing under SLS. So we can make those modifications later. And again, the reserve factors table. So let's generate the report. So the report has been generated. So if we see the summary, so this would give you the overview about what exactly is the issue with any of these things. So let's just start with the assessment report of element number 3. You can also verify this once that where this 3 factor comes from. So you can visually also see that this RA by SA is what is giving this adequacy factor. This psi and psi star can also be verified. So the special vehicle reserve factors with standard vehicle and without standard vehicle. So as we saw earlier, that you can also verify this manually by checking where exactly these values come from, but you don't need to worry about it because you can see that it is reported correctly. You can also verify them later. So for the flexure, it is coming out to be safe. For shear as well, it's coming out to be safe for sections. And as we saw in the SLS checks, some of the elements are failing for this. So here you can see in element number 3, some of the cases for the fx mean and fy max mean are failing. So you can rectify the model later. Similarly, you can check the same for the 7th element as well as for the 51st element. But for now, we are interested now in the detailed report that is generated by the program. So as you can see, this would give you a very detailed idea about what factors the program has used, how the assessment resistance is calculated. So this is more with regards to the capacity. So as you can see, the partial safety factors for the ULS as well as the SLS, the material that is being considered, the pre-stressing steel information. So there are 4 tendons passing throughout an section, a girder. Then the non-pre-stressing steel information, the rebar information is provided over here. Then we can see the flexure design for a section for the moment direction. So this is for the positive case. And here you can see that this is the maximum moment that is induced on the structure, 8572. So we want the moment to be more, our resistant moment to be more than this. So it will perform the analysis, the checks as per the calculation of neutral axis. So it will find the neutral axis. And the neutral axis is around 215 mm. MU, which is the ultimate moment resistance for the positive case, is around 26,000 kilonewton meter. So it is much more than this moment that is applied. So it is okay. So after applying the factor, you can confirm that it is okay. Negative, there is no negative for this case, so it is skipped. Similarly, for the shear design, as you can see, the axial force due to ultimate loads, the shear force and the bending moment is captured. So this is the effect, load effect. And then as we already saw in the presentation, first it will check whether the cracking is, the section is cracked or not from the cracking moment. Since the M cracking is more, therefore the section is uncracked. Then the shear resistance of the concrete is checked. This, all of the codal provisions are also being shown in the report. So you can go back to the code and check, even if it is, let's say if you go and see any of the things which is failing, you can go back and check what exactly the code prescribes and how you can modify that. So coming back to the shear, this is the ultimate shear resistance of the concrete. This is VC and shear reinforcement, VUC, and it is checking for the reinforcement, for the longitudinal reinforcement required, whether the shear links are effective or not. So shear links are effective in this case. And then the shear resistance check, VU equals VC plus VS. This is the ultimate shear resistance, which is much more than the applied, which is 357 kilonewton. So hence it is okay. Now the torsion design checks are skipped. For the serviceability ones are pretty straightforward because it's just 0.5 ton. This was earlier provided in BD44. So this what CS455 has superseded that. So you can find that over there, which is 0.5 times FCO by gamma MC. And the limiting value is 16 MPa as given by the code, and no tension is allowed. So limiting value for tensile limits is 0 MPa. And as you can see that the values reported by the program is exceeding the limits for both the tensile as well as compression cases. So it is not good. Similarly, you can check the same for the other cases. So in this way, the program generates the MS Excel based report where you would be able to see the details of the entire section, what exactly it has taken, what codal clauses it has referred to. And after this, we already saw the tabular format results over here where the program would give us the flexural reserve factors table and the shear reserve factors table, torsion ones, SLS. So you can also confirm them once at your end. So in this way, today we saw what is the workflow which you need to follow in MIDAS Civil NX. Now going back to the presentation. So we already saw the software demonstration. Now next is the Q&A. So we can start with any questions, if any.